Recommendations for electronic circuits prototyping. Use a 30-watt soldering iron to solder a component in Vero board. Use a soldering iron and sponge with water to clean the tip of the soldering iron. Use a good quality soldering wire to wire up your prototypes. Use a proper wire wrapping wire to wire up your prototypes. Use soldering fume extractor to protect yourself from the fumes of the soldering wire. Use a good quality tin coated Vero board for your prototyping. As we have completed the circuit of RS232 interface, now we'll perform a connection test between DB9 connector and the computer. We'll perform a data loopback test from the computer to the DB9 connector. For this, we'll short circuit pin number 7 and 8 of the ICL232 IC. It means that we'll create a short circuit between pin number 2 and 3 of the DB9 connector, which is TX and RX of the DB9 connector. And here we can see pin number 7 is connected with pin number 2 of the DB9 connector and pin number 8 is connected with pin number 3 of the DB9 connector. Now we'll create a short circuit between pin number 7 and pin number 8 of ICL232 IC base, and we'll connect the RS232 to USB interface with our DB9 connector. Here we have inserted a jumper between pin number 7 and 8 of the ICL232 IC base. It means that we have created a short circuit between pin number 2 and 3 of this DB9 connector. Now we'll connect the RS232 to USB interface with our DB9 connector. Now we'll go to the computer, and in this PC we'll go to the Manage, and in Device Manager we'll check the ports, and here we can find we have a USB to serial conversion interface at COM port 3. It means that RS232 to USB conversion interface is detected on COM port 3. And now we'll go to the micro C. In micro C we'll go to the tools and we'll go to the USR terminal, and here we will select the COM port 3. Now we'll connect the micro C USR terminal and we'll press the connect button. Okay, COM port 3 is connected with USR terminal. Now we'll send a string and we'll check if the string will loop back from the DB9 connector. So here we'll write ABC. Now we'll press the send button. Okay, here we can check the string is looped back from the DB9 connector. It means that the RS232 to USB converter interface is working properly. We have tested the connection between ICL232 IC base and the DB9 connector. Now we'll check the IC of ICL232. For this, we'll remove the microcontroller from the base and we'll create a short circuit between pin number 25 and 26 of the microcontroller, which is TX and RX port of this microcontroller. And now we'll place this jumper on pin number 25 and 26 of the microcontroller. Here we have created a short circuit between pin number 25 and 26 of the microcontroller. Now we'll insert the ICL232 IC in the base and we'll perform the same data loopback test as we have performed earlier. Here we have inserted ICL232 IC in the base, and now we'll power up the circuit to energize ICL232 IC. And now we'll send the same string as we have sent in our previous test, and now we'll press the send button. Okay, here we can check we are receiving the same string as we have transmitted through RS232 IC. And now we'll write a simple program to loop back the data from the microcontroller. In micro C, we'll go to the project, new project, the standard project, and the project name is serial data test. And the project folder will be in micro C projects. We'll create a new folder and the folder name will be serial projects. OK. Device name is PIC16F877A and the device clock frequency is 10 MHz. OK, next. Finish. And here we have our main program starting from void main. OK, save. Now we'll go to the help, and in help we'll go for Micro C Pro for PIC libraries, and here we'll select UART library, and here we can find library routines, that is UARTX initialize, UARTX data ready, UARTX TX idle, UARTX read, UARTX read text, UARTX write, UARTX write text, UART set active, and here we can see generic routines, that is UART data ready, UART text idle, UART read text, UART write text, and here we can check from the sample program that how to initialize the UART. Here we can see UART1 initialized 9600. It means that UART1 is initialized for 9600 baud rate. So we'll copy this command from here with delay prototype, Ctrl C, and we'll paste the command here in our main routine, Ctrl V. Now we'll go to the micro E libraries, and in system libraries we will select UART library. We'll go to the help again, and here we can find in while loop that how to read the data from UART and how to write the data on UART. So we'll copy this while loop from here, Ctrl C, and we'll paste the while loop here in our main program, Ctrl V. Here we can find a variable that is UART read, and here we can check in sample program that how to define the variable. So we'll copy this variable from here, that is Ctrl C, and we'll paste the variable before main program. Ctrl V. Here we can check we have initialized the UART for 9600 baud rate, and here in while loop we are checking if UART data is ready. Then receive the data in the variable that is UART read and write the data from UART variable to the serial port. And now we'll compile our program and we'll observe the result of our program on our prototype. Here we can find an error on line number 12, that invalid expression. And here we have to insert another curly bracket for our main routine. So here we'll insert a curly bracket. And now we'll compile our program. Our program is compiled successfully. We'll go to the serial projects, and here we have the hex file, that is serial data test. OK, write. And now we'll go to the micro C USR terminal. Here we can see the COM port 3 is selected. Now we'll connect the COM port 3 with USR terminal of micro C. OK, connect. Now we'll send the same string as we have sent in our previous test, and we'll press the send button. OK, here we can see we have received the same string as we have transmitted to the microcontroller. It means that our program is working properly, and the UART port of the microcontroller is also working properly. And here we have our previously written program. Now we'll try two more prototypes, that is UART text read and UART text write, and we'll go to the help. And here we can find in generic routines, that is UART read text and UART write text. And here we can find the prototype, that is UART X read text, that is void UART X read text, character output, character delimiter, character attempts. And here we can find an example program, that UART1 read text. Output is the variable in which we will receive the string. OK is the delimiter, and if the prototype will find OK in a string, then it will terminate the receive string. And the number 10 defines that how many characters will be received in our receive buffer. And here we can find another prototype, that is UART1 write text. Output is the variable in which we have received the serial string. Now we will use these two prototypes in our program. So we'll copy these two prototypes from the example. Ctrl C. And here we'll comment our previously used prototypes. So we'll select these prototypes and we'll select the comment. Now we'll paste the new prototypes in our while loop. Control V. Here we have to define the variable that is output. We'll define a new variable before main program. We'll also comment this character variable. And here we'll define a new variable that is character. And the variable name is recstrg, that is receive string, and we'll define the length of this variable as 20 characters. So here we'll define 20, and now we'll replace this variable with the variable that is output. So we'll copy this variable from here, Control C, and we'll replace this variable here, that is Control V and Control V, and we'll also replace the delimiter, that is %. It means that the prototype, that is UART1 read text, will terminate the string if it will find a % sign in receive string, and the number of attempts are 10. Now we'll compile our program and we'll observe the result of our program on prototype. In serial projects, here we have the hex file, that is serial data test. OK, write. Now we'll go to the tools. We'll select USR terminal, and here we can find we have two COM ports, that is COM port 1 and COM port 3. RS232 to USB interface is detected on COM port 3, so we'll select COM port 3. Now we'll connect COM port 3 and we'll write a string, that is ABC, and we will add a delimiter sign here, that is % sign, and now we'll send the string. Here we can find we have received the same string as we have sent to the microcontroller. Now we'll add some more characters after % sign, that is DEF. It will clear us the concept of delimiter. Now we'll send the string. Here we can see we have received only 3 characters because of this delimiter. And now we'll add a buzzer circuit in our prototype. Here we can find the buzzer circuit that we will interface with our microcontroller, and we can see the buzzer signal is connected on pin number 15, that is RC0 port of this microcontroller. So we'll develop this circuit on our prototype, and here we'll place the buzzer in our prototype. We have soldered a transistor, that is Q8, in our prototype. Now we'll connect the capacitor C13, that is 2.2 microfarad, with power supply of the buzzer. And now we'll connect a resistor R40, that is 2.2K, between the base of the transistor and the pin number 15 of the microcontroller. Here we have completed the buzzer interface circuit for our prototype. Now we'll write a serial communication program to control the status of all 8 LEDs. We'll also control the status of the buzzer. We'll read the status of 4 switches. We'll also control the status of these 2 relays. We'll switch on and switch off the tri circuit from the master terminal unit over serial link. And we'll control the PWM signal to increase or decrease the analog voltages from the master terminal unit. We will also read the 4 analog channels over serial link to the master terminal unit. Here we have completed our embedded prototype, and now we'll develop the serial program to communicate our RTU with the master terminal unit.